This is Doug Lewis, your Math 107 instructor, and this is just a brief introduction to the finance unit in the online course. I want to talk to you a little bit about the formulas you're going to use and the calculator program that they're going to introduce to you in other videos, and just a couple of the basics of some simple type problems that people tend to miss. I want to address those before you get started, so you just have to be on the lookout for those. Okay, so I'll go over those formulas with you right now. These first formulas, this is a simple interest formula, usually introduced in a beginning or pre-algebra or basic algebra course, where the interest, but just to calculate what's called simple interest, you calculate the interest by taking the principal times the rate and times the time. Your book will probably use the formula P sub 0 for principal, R for the interest rate, and N for like the number of years something might be invested. Now, or this could be a fraction, like if you want to find the interest just for 1 month on a, let's say, a home loan. Maybe you borrowed $100,000 at 6%, and it would be 1 month would be 1/12 of a year, so that would be the length of time. This is the time the investment's made. So for a month it would be 1/12. A lot of the problems to calculate interest, we're going to see we do them in a different way, and I'm going to show you later in this video how we do those. So this should be a formula you're familiar with, and this will be used a little bit in this section, this unit. The compound interest formula will also be used. That is when you make a one-time investment, and the only money that's added to that is the interest that you're earning. And so this is the compound interest formula. You've probably seen this is your initial principal. This will be the interest rate again. R is typically the interest rate. K is the number of compoundings a year. And then N would be, again, the number of years or the length of time you leave the money in. And, of course, there's K again. These values of P, principal, R for rate, K for number of compoundings, and N for the number of years, which can be a fraction. If something's left in an account for only 6 months, then N would be a half if it was an annual rate. Okay, so those are formulas that I hope you've been familiarized with already in previous classes. Now, the two new formulas that you're going to be learning in this class, one is the retirement savings plan, which is similar. You can see some similarities to the compound interest formula. We have a 1 plus R over K to the NK power again, and this is a D instead of a P, and then there's the -1, and this is a little different too. And the reason it's different is because this is a kind of plan where you'd put money in on a regular basis. So you'd be making multiple deposits. So the reason it's more complicated is you're not only earning interest on every time you make a deposit, you're also adding your own money month after month after month, or year after year after year. And again, similarly, R is the interest rate, K is the number of compoundings, and that K has to be compoundings, has to agree with the number of times you make an investment. So if you make monthly deposits, then K has to be a 12, and it has to be compounded monthly. If you make annual deposits, then K would be 1 for once a year, and you would be compounding your interest once a year. So the number of deposits per year is what K would have to agree with, and D is the amount of deposits of each deposit. Now, when you get money back from a retirement savings account, or when you pay back loans, this is the formula you'll use. And you can see it's a little bit similar to this, but notice this has no negative in the exponent, and you subtract a 1 here. On the annuity payout, where you get money back or you're paying off a loan, then you have 1 minus this same 1 plus R over K, and notice it's a negative NK. So be careful when you use this formula. Now, the in the videos, you will be taught a way to use the calculator instead of having to use those formulas, because there's an application for finance on your calculator. There's my button is kind of purple, apps. You hit apps, and then finance is the first thing you'll hit. And then it's called the TVM solver, and there's videos on how to use that solver and how to plug values in to do that and how to calculate the answers. So if you have questions on that, you can ask me on that too. Anyway, now moving right along, those are the new formulas you're going to see. Now, I know there's a way of calculating simple interest, but many of the times you'll be calculating the amount of interest that you either earn on an account or that you pay into an account, and you'll be calculating that based on actually knowing what you put in and then knowing what is available to pull out. And so how much interest was earned on something is when you have an investment, you put the total final value of the investment in. That's your first value, and you subtract your total number of deposits, because you could be making many deposits over many years. So here's an example. If you make deposits into an account of $200 a month for 20 years and your interest rate is 6%, how much will you earn over the life of the investment? Well, again, I told you that you'll be using, this is a retirement savings, so you'd be using this formula, or you'd be using your TVM solver on your calculator to do that, and you'll get this number. If you put $200 a month away for 20 years at 6%, you will earn, your value of that investment at the end of the 20 years will be $92,408.18. Now, how do you calculate the interest earned? Well, you never once do an interest calculation actually to find it. You take the total final value, that's the $92,408.18, that's your total final value, and you subtract how much you put in. That's a simple way to find the interest. And so you put in $200 per month, we usually write that like that, times, you do that 12 months per year, times 20 years. So our months obviously reduce, our years reduce, and we'll be left with just dollars. So the number of dollars that you deposited would be 200 times 12 times 20. Well, I can do this quickly. If you go 0, 0, 0, you know you're going to get 3 zeros in this number. And then you get 2 times 12 is 24, and 24 times the 2 is 48. So that's going to be $48,000 that you put in. And what you got out is $92,408. So if you take that $92,408.18 and subtract the $48,000, then it's pretty obvious you're going to get, there's your 408.18, and then 92 minus 48 is 44. You can do some borrowing there, but that's that's $44,408.18 of interest. It's kind of astounding, isn't it? It's called time leveraging. If you can invest for a long period of time, that interest builds up a lot. So look at that, 44,000, almost doubled your investment, all the money you put in. So now there's also, it's wonderful for you to be able to earn that much interest if you start investing in a retirement plan, but a lot of times you end up borrowing money. Well, those people that loan you money, well, they're going to make interest off of you. So here's how you find out how much interest would be you'd be paying if you borrowed money yourself, or how much interest you could get if you were having an annuity payback. So this is on loan payback or annuity payback, either one. They use the same formula. So if you borrow $12,000 at 5% interest compounded monthly over a 4-year period, it says how much will you end up paying on that loan if you're making monthly payments. So there's a way to calculate. Now for this problem, you could use this formula to calculate your monthly payments. That would be D. So you'd have your 5% 12 times a year for, this is a 4-year period, so n would be 4, and there would be your, again, your 5% for 12 times a year, and you could calculate all this, and then your loan value would have been $12,000, and you'd find D. So that will be something you'll be working on in the class. I'm going to give that to you in this right now for this particular problem. It says if you borrow $12,000 at 5%, this will be your monthly payment. Well, you borrowed $12,000, so that's your initial loan or annuity value if you were getting money back. And you want to know what the total amount you paid is. So if your monthly payment is $276.35, that's per month, and you do that for 12 months per year, and you do that for 4 years, again we get the same things. Our months reduce, our years reduce, and we get 4 times 12 times 276.35. I'm going to do that on my calculator. I can't do that as easily on my head. So of course 4 times 12 is 48. So we get 48 times $276.35, right? So we have 48 payments at $276.35 per payment. That is $13,264.80. So that's how much you have to pay back. And you only borrowed $12,000. So you're giving them more than they gave you, which that's the way these loans work. That would be $1,264.80 in interest. Okay, that is the end of this video.